availability requirement here. If you see there is something wrong, you need to have the data to let the contract to execute that data so that the contract can realize whether there was something wrong or not. And then, so technically what happens is the challenger has to force the contract to execute the entire batch and see whether the emulated state actually ends up with the same state that the proposer had published or not. If they don't match up, then it shows that the proposer did something wrong. And as a the direct consequence of that is this execution is limited for how much opcodes and how much process that you can use in the L1. So if L1 doesn't let you to process 10,000 transactions, then you never can actually challenge a batch that contains 10,000 transactions, because there is no way that you can actually fraud proof against it. So the scalability of the optimistic rollup is bounded to the how much process that you can run within the L1 per transaction. Sorry. And another issue is inside Ethereum you cannot run another EVM on top of EVM. So why do we need that? Because if you assume this L2 network is itself another EVM, EVM is Ethereum virtual machine compatible. That's what I'm talking about. And you cannot you cannot tell EVM that, hey, let's run this EVM with this old state and see what happens. You need to emulate the EVM on top of EVM. You need to create some interpreter or do other fancy stuff to make that happen. And it turned out to be extremely hard. You cannot preserve all the opcodes when you're emulating that EVM, that second EVM. And especially let's say the state read and state write opcodes that we already have in EVM, they cannot be used off the shelf with the second EVM. You need to change them, because if you call the state read opcode, then it reads the state from the L1 state, but we need to be read from the L2 state. So we need to change so many things, and because of this change, it's just technicality. The transaction fees gotta change, and so when you're running the same shit on L1, you end up with a different result. And these things also, they're just edge cases that you need to consider, and because of that, this non-interactive has so many issues. And there is also two other issues that are so important and so funny at the same time. Let's imagine we are waiting for someone to challenge this new batch. Then what is the economic model for this challenger? They need to wait until forever and hope for the best that they can finally find some wrong state and then challenge against, and probably give earn some reward. But I don't think if that ever had happened in any of the optimistic rollups history, no one ever could challenge them because they were all doing the right thing. So the equilibrium of this game becomes the challenger don't do anything, and the optimistic rollup can start doing fraud things because there is no challenger. And there is also another issue which is a bit technicality. You also need to give everyone some time so that they can download the data, execute it, and see if it makes sense or not, and then upload the data to L1 contract, and so they can run it, see, do the fraud proof protocol. Okay, now the first category sucks. Just forget that. It's time we introduce the second category, which is interactive protocol, and it is basically the interactive protocol between the rollup submitter, sequencer, whatever, and the person who claims that there is a fraud happening in this batch. And so in high level, the party and these two parties try to bisect this big chunk of execution trace into half, and then try to decide which half of these which of these two halves have some issues, and then they do it all the way till they reach a single opcode, and then ask the contract to only execute that single opcode and see if it makes sense or not. So in the previous model, we had non-interactive, and the contract had to execute the whole chunk, the whole batch of the blocks, which was capped by some limitation and also had so many issues. But in this new model, because the interaction allows different parties to split the execution path to just one single opcode, then it's much more doable than the other one. And also here I brought some picture. It's from Canon, which is the new fraud-proof model for optimism. And yeah, I borrowed this picture from them. So technically what happens is on the top we have the batch of blocks. It's like thousands of blocks or whatever are lying there. And someone challenge against that, which is this like red arrow here. Someone introduce a challenge on that, opens a challenge, and then what happens here is the protocol just inductively goes down the row. So the challenger and the proposer now try to run the protocol against this route. And again, like the proposer probably proposes 3 different routes that is correspond to 3 different split of this whole execution chunk. And the challenger tries to find which of these chunks don't make sense. And so again, they go do it on and on until they reach to a single opcode, which is right here. And so the smart contract can run this too easily. And also, there is another fun fact about this protocol, and that's there are not only 2 people who are involved in this game. Many other people can just jump in and challenge the other person. So, for example, let's say the challenger is not honest. What happens if there can be another challenger that like can start challenging the challenger itself? And so there are some cases that the challenger is not honest, so they also have to be punished for like just consuming whatever thing that they shouldn't do. Okay. Yeah, so there are some good things about this interactive version. The dispute protocol ends up with executing a single opcode, and you're not bounded with AVM. But still, we need someone to get this data to the smart contract. Again, there is some technicality. I know that we already have posted data on chain, but then the data, because of the way that the Ethereum is designed, is put somewhere else, and the contract doesn't have access to that at the moment. And also it depends on so many other factors in the design. But still, there needs to be someone to post some data onto the contract. And then it's again not completely EVM compatible. It is, but not too easily, but it's still doable. And probably the disadvantage of this method is because we have like now the interactive protocol, we need to wait so long time for them to resolve the issue. Like for example, in some cases 12 days or like 17 days or so. Okay, so just to wrap up, non-interactive had data availability issue, no good economic model, cannot be completely EVM compatible, and also bounded via Ethereum execution limit, which also was time-consuming fault-proving mechanism, but it's not as time-consuming as the other one. The other one we had data availability, but is again still better than the other one. Again, we had the economical issue, and again it's still built a single place. Like it has some cap, as you already saw. There are some limitations to like how much execution you can have. But what we're gonna do is to have a network of rollups, and this network must share the same infrastructure. But actually, do they solve the issues that we raised before? And here I again depicted the issues. One of them was liquidity fragmentation. We don't know. Maybe network of rollups can do that. And message passing delay, we still don't know. We should figure that out. Composability issue, again, I don't know. And the security diminishes to the network with a low safety. We at least solved this one theoretically because we are all just tight with Ethereum. If the rollup is designed in the best way that it should be designed, then the security is adopted from Ethereum. So the safety is no longer an issue if it is done in the right way. And much more, okay. So, one architecture that people have proposed so far was L2 plus L3s. And in theory, we can have a rollup which can like live here. It's our L2, and then we can spit out so many other L3s that are attached to this L2, and it kind of like facilitates with the communication across different rollups, because we can customize this one in a way that we want, so that the messages can be passed like quicker than usual. And also the EVM compatibility issue, we can change the EVM on this rollup, the virtual machine on this rollup, so that these ones can just become so much more compatible with the L2 rather than the L2 compared to the L1. So there are some flexibility in this design, but also there are some issues, and most of the people use this model instead, where there is a single bridge in the Ethereum, which is a contract, and many rollups, many L2s connect themselves to this bridge, like subscribe to this bridge. And so and I think for the rest of the talk we're going to talk about this model. Okay, they still can choose whether they want to be interactive or non-interactive in the fraud-proof case, fraud-proof sense. And now let's reiterate: if they're non-interactive, do we have the data availability issue? Like how would it be in the long term, in the end game? It would become too hard, because now we have multiple rollups. It's not just a single L2, and we had the data availability issue for one of them. When we have multiple of them, then we need to store many like much more data, which is kind of impossible. And economical model sucks even worse than before, because now the challenger has to challenge so many different rollups and cannot be completely compatible. Yeah, that's true. Again, bounded by Ethereum execution limit and also time consuming for fault proof. Whereas in the interactive one, the data availability is the same as before, but then the economical model still have some problems because there are multiple networks that are involved, and also the challenge period is still extensively high because like this interactive mechanism between different rollups, and but the whole like point of having the bridge here was to actually facilitate this cross rollup communication. But if any of them are using interactive fraud proof protocol, and any of them needs to wait for 12 days to see whether the state that this proposer is proposing is right or not, then this bridge theoretically can't do anything with that. So still we are bounded with this like delay for cross L2 communication. And okay, so here I brought the superchain protocol. Oh, by the way, this one was the picture that I adopted from superchain. I borrowed from them. And the design that they're proposing at the moment is everyone can challenge every of these L2s. So if you, for example, if you're a challenger and you see one of these state updates that for any of these L2 doesn't make sense, you can initiate a challenge. And there is a set of attestors who is listening to these challenges, and if they see any of the challenges make sense, they vote through a consensus mechanism, and this consensus thing just outputs an initiating of interactive fraud proof protocol. And this interactive fraud proof protocol has to be done in L1, as I said before. So now there are two steps. The challenger start to challenge, proposes a challenge, and attestors vote for the challenge. If it got enough votes, then the protocol actually initiates the interactive fraud proof protocol in the Ethereum. But now there are lots of issues. One of them, consensus mechanism. Okay, multiple chain security, they just all broke. Why? Because when we have multiple L2s, then we have less challengers per each of these L2s. And also we have less attestors per each of these L2s. And if you remember, for consensus mechanism, consensus algorithms, we always have an assumption that like 2/3 honest majority or 1/2 honest majority, at least some of them has to be on place. But because we are already dividing the number of attestors and number of challengers by the number of roll-ups, then with probably high probability, you will end up with a roll-up that doesn't have enough honest attestors on honest challengers. And because of that, the safety of one of the roll-ups is not guaranteed. And so it gets even worse. You can imagine the world that one of the roll-ups is not secure, and the bridge is claiming that they can transfer messages before the challenge period or whatever, and so they create a message that is not true, transfer it to another rollup, and drain some vault in another rollup, and then do this with many other rollups as well. And so no one can actually challenge this because there is no challenger living in this faulty rollup that are honest. So that breaks the whole thing. The economic model, it's now extremely hard, even harder than before, because now we are two different actors. We have two different actors. Before we had just challenger, but now we have attestors as well. And so it's really not clear how they're gonna manage the funds, or how should challenger get rewarded, how they should just get punished or whatever, unless attestors reward also is in place. And then again, the challenger has to wait until probably forever. So because of that, the equilibrium of the game pushes them to just don't do anything and just chill. And so it exacerbates the other problem that we had before. There is no honest challenger who is actually operating on the network. And what happens to the cross L2 message passing delay? We already have lost the safety because of the issues that I mentioned. And so fast message passing is just the nightmare in this system. We need to at least wait until the challenge period is done. Otherwise, we probably end up roll back the sum of the roll-ups, and it's not so clear how they're gonna do that. So I would say that also doesn't work. Not easy, at least. And what's the end game? I just brought some resources here for you to see what optimism and Arbitrum and other optimistic rollups are doing. I literally copy pasted this one, and so they're saying zero knowledge proof? They are switching the the fraud proof mechanism to ZK, and that's the things got so interesting. And again, Succinct Lab, literally a week ago, they actually did it. They created a L2 via optimistic stack, and they changed the fraud proof to zero knowledge. Again, another tweet from here. So they're all switching to zero knowledge fraud proof mechanism, which is ZK rollup. They are no longer optimistic rollups. And yep, that's all. I hope I convinced you all. And also, here's my Telegram, Twitter. Let's follow if you want to. Questions?
Is there any chance that all this computation can overwhelm the Ethereum network?
Can you do it again?
Is there any chance that all this building these L2 and L3 and blockchains on top of Ethereum, is there any chance that it would overwhelm the Ethereum compute capacity?
It wouldn't overwhelm. I mean, it depends on what do you mean by overwhelming, because there are now two factors. One of them, as I said, is the data and the storage that they are using from Ethereum, and the other one is the execution that they're using. The execution is pretty cheap, but the data is going to be too high. And so that's why EIP 4844, 4444, they are trying to increase this capacity for rollups via the blobs and increase the number of blobs and dank sharding and whatever else. I don't see an issue even in long term for that, but one thing that I'm personally worried about is that when we have multiple rollups, when we are just moving this this user interesting dApps to rollups, then the source of MEV that coming from the whole blockchain system is from probably DEXs and lending protocols and other dApps. And right now they all the most interesting and attractive ones are living in Ethereum, for example Uniswap, and people are interactive in Uniswap. And so who is getting the MEV out of these trades? They are L1 validators. But if you put Uniswap in one of the L2s, then that's the L2 validator who is absorbing the MEV price, MEV reward. So kind of it diminishes the attractiveness of becoming L1 validator. People try to go and do the validation and sequencing for L2s, and so it decreases the safety of the L1. And so there are many other factors. It's not just the overwhelming issue. There are other things as well into play. And
What about gas costs for running this stuff on Ethereum?
Gas cost? It depends on how much storage they have. Right now, the blob's gas cost is changing every now and then. Sometimes it's too high, sometimes it's too low. But if they fix the issue with the blobs, then the gas cost wouldn't go that much higher.
So there are, like, I have heard a lot about MEV kind of moving away from ETH and how it's a big problem. How much, like, how valuable is MEV to validators right now? Like,
A lot.
more than
It's more than block reward even
Okay.
right now. So it makes sense to
yeah.
pivot. Yeah.
So we've kind of hyper optimized for L2s. So we now have the infrastructure on L1 that we can run these L2s without being extremely expensive, right? But now nobody's using L1.
Yep.
Interesting.
That's why like the base sequencing and things like that probably
base
are the most viable solution, because
Yeah, like base
there
report.
is a way that you can again direct the MEV profit to the L1 validators via the base sequencing.
Other than sequencing, any other things that you can think of?
Not at the moment. That's also just my personal opinion.
Yeah.
I'm not like expert on sequencing, but
I guess to kind of promoting the safety of using an L1. So if you are a large market maker or whatever, I mean, you kind of have to move to these L2s if that's where the liquidity is. But yeah, maybe promoting safety of using an L1 rather than an L2.
I'm not like in the favor of doing that, because if you want to have a viable system and safe, you must theoretically prove that this system is going through a safe state, through
So-
like game theory or like math or whatever. But if you're expecting user to be just polite and do what you want, they won't.
Right. But like, if let's say as a community we promote that the safest way to hold your Ethereum is by keeping it on L1.
Then they have the issue that the L1 transaction fees are too high. So
Yeah,
that's
okay.
like, I mean, there are many reasons why we have L2s.
Yeah.
So what do you do with that?
Yeah.
Do you want to make L1 scalable? You want to make transaction fees too low, and so that's why natural choice for user is to just move to other networks.
Yeah. I mean, right now, it's not very expensive.
Yeah, it's
right?
not very expensive, and also there are not many people who actually move to L2s. But we are talking about endgame.
Yeah.
We don't know.
For the end game, I saw in like the Ethereum AMA, there's like why doesn't Ethereum do what OP did with Succinct or something like that? Would that help remove the need for reliance so much on L2s for like?
Actually, I haven't saw the like most recent AMA. And can you like tell me
I'm not
about?
the most best person to ask to summarize, but I think they were talking about implementing some sort of ZK fraud proof with snarks. to make
Okay.
stuff faster.
Okay, gotcha. So, I think that's where I mean by we I mean the Neil Foundation, we are heading again. We're heading to. We're calling ZK sharding, and I personally believe that can be a kind of end game, but the most not the most, but one of the challenges there is that we need to actually prove consensus through ZK. It's not just execution. There are many other things as well, and that's pretty interesting topic. And it turned out to be doable. But yeah, you can imagine like we have so many rollups, and the thing that Arbitrum is doing, like optimistic, what was that? Superchain is doing. You can imagine just replace all of them with ZK rollups, and so that then become interesting. You have some consensus of chain, you have some ZK rollups off chain, and so they can probably like much more securely interact with each other and post the like final result on chain. Ethereum theoretically can become like that, but it's just so much speculation. 15 plus year, I would say. Because like even before that we have like this FHE and polymorphism, I mean that would like make so many changes. So I won't expect that Ethereum become a multi-sharded ZK network. Maybe never. But instead they will become infrastructure for other people to make that. Can you move it a little bit? Like
Sorry, I came a bit late, but the most recent slide was about like issues with L2s and the challenger and attester stuff. Like, I don't think we've seen any exploit or economic attack or consensus attack that like where the attacker profited from these kind of vulnerabilities. But if, like, what are you viewing as like the most high risk sort of like vectors of attack given this like increased role of activity?
Okay, maybe I can ask another question to answer your question. Do you remember back in the day when Ethereum was proposing, like before the merge, they had different opinion and they had different roadmap, and so they also were building a lot of things based off of that, and then they realized there was an issue with the consensus algorithm, and if they don't care about that, everything just broke. So they changed so many things. They proposed other like Vitalik paper for Gasper and Casper and stuff like that happened after that. What I'm trying to say is that community and the developers like do care about this stuff, even if the attack doesn't happen, but it might happen, and because of that you need to change the whole system and design. And maybe again another interesting question: do you feel that Ethereum at the moment has 2/3 honest majority, or more than that, or less than that? I would say it's more than that. But then why do we scale, like why do we optimize for 2/3? Because that's the math like is telling us to do. So I think probably it's not so, this part doesn't sound so critical to you, but it is critical, believe me. We have outlined some results literally this week. I can probably give you the link or whatever. It's for our company, like New Foundation. And we proved that once a year, like with some like parameters and number of validators, once a year it actually may happen with high probability that one of these rollups become malicious and they mess up with the whole network. So that's so serious. And I mean the rest of the items also can become a discussion for itself. But you're welcome.
So back to the moving to ZK, they're just kind of using ZK fraud proofs, right? It's not necessarily ZK proofs for every transaction. It's still optimistic.
Oh, okay. That's a pretty interesting question. There are two things. One of them is ZK like validity proof, and the other one is invalidity proof. I'm guessing they are doing validity proof because, okay, how can we make an invalidity proof based off of invalidity proof? If you prove that this transaction list ends up with this result, the state root, the new state root, and this new state root is different than the other one that the proposer has proposed, you could actually prove the invalidity of the state root of the previous one.
Yeah, but it's less expensive. So it's less expensive to prove the invalid.
Yeah. But I'm not sure if they are doing that. It's just my personal opinion because we also have the same issue. That's why I proposed to ZK sharding.
Oh.
But I'm guessing it makes the most sense to do this way.
So sorry, it makes the most sense to have just fraud proofs ZK, optimistically post transactions, and then post a proof if one is incorrect? Or are you saying that just do ZK validation for every single transaction?
No. I would say second one makes the most sense
Mm.
Because the first one, what happened? What if the prover is not working?
Well, if the
Then we are just
prover's not working, the second one doesn't work either, right?
no. The second one doesn't proceed.
Yeah.
You have to wait until the prover give you the proof.
Okay. So if prover went, there was a bug with the prover.
Yep.
Then you have to rely on the prover.
I mean, even if you have decentralized prover network, then still you're adding some security assumption on top of Ethereum that someone in this decentralized network is actually proving for you.
So what if you have like backup fraud proofs? So if you really want to, you can do the current.
You're just like trying to become L2, but you actually are not L2 anymore. As I said, like the L2 is the network that has exactly the same safety as Ethereum and the same liveness as Ethereum. But if you're adding too many assumptions, then you're not that L2 anymore.
Those assumptions just kind of add a time delay, though, right? Like,
yep.
So the window of time, it should just be instantly verifiable as soon as the transaction is posted.
Just make sure that everything is correct and then put it on chain. If you're doing anything other than that, then something doesn't make sense.
Yeah. Okay.
Personal opinion.
What if you want 1 million transactions per second and you need a AWS 6 extra large machine to approve it, and then the only person that ends up proving it is the foundation itself?
I think there are some theoretical limits to million transactions per second. You cannot even if everything is going well, it's not possible.
Okay, fair enough.
No worries.
What do you think of mega ETH then? Or those kind of centralized, like high hardware requirements? Sorry.
No worries.
What do you think of mega ETH then, and those kind of like design trade-off, like high hardware requirement, low decentralization?
You weren't here.
Sorry, if you covered it, you don't need to.
You didn't cover Mega ETH, but we covered Monad,
Fair.
which has a better like, even they claim even more than Mega ETH. So that's the limit. Can they actually achieve like 100,000 transactions per second? I don't know. It's a question to ask. But also, even if they can, are we looking for 100,000 transactions per second? Like we are creating infrastructure for life living, or like let's say IoT devices connected to blockchain, cars connected to blockchain, like any other things. So that's not what we're looking for. And I believe Mega ETH, Monad, and there are also like many other projects who are trying to do that. They are like fundamentally limited to the single process. So there's not single process but single machine as well, at least. So they have some limitation, obviously. Yep.
Thank you.
Thank you.
Welcome.
Yeah, Tango's not back yet. But yeah, make sure we have a new POAP at the back there on the poster beside the doodle. You can tap that and grab our POAP for the week. Thank you, Radney, and we'll see you next week.
Yep.